Thank you for your interest in my presentation titled Is All Explicit Awareness Equal? Comparing Instructed versus Induced Rule Knowledge in a Semi-Artificial Language. My name is David Abugaber and I'm a PhD candidate in Dr. Kara Morgan-Short's Cognition of Second Language Acquisition Lab at the University of Illinois at Chicago. Now, perhaps on second thought, a better title for this talk would have been Instructed versus Incidental Rule Knowledge, because induced and induction are often used to refer to paradigms where all participants are led to become consciously aware of a rule, and that's not quite exactly what we did. So sorry about that confusion. Anyway, let me get right into an overview of what we'll be presenting. The implicitness of learning is a big topic in second language acquisition. Prior studies suggest that participants can learn L2 grammar regularities even in the absence of conscious awareness of these regularities. Now, a study by Battering and colleagues in 2014 reported no differences in reaction time-based measures of grammar learning between rule-aware and rule-unaware learners in an incidental learning context. We aim to extend Battering and colleagues by examining how grammar learning differs when metalinguistic awareness comes from incidental versus instructed conditions. Now, I should mention that this is based on reaction time pilot data for my dissertation, for which full EEG data collection has been halted by COVID. So we're trying to do what we can with these reaction times. Note that the incidental and instructed participants have actually vastly different sample sizes, and the data were collected at different time points in the year. I'll get back to those points later, but just wanted to give a little bit of context about that. So, some background for this study. Awareness, attention, implicitness, explicitness is a massive topic in the field of second language acquisition, with more than 150,000 hits on Google Scholar for such keywords, and lots of published books specifically targeting this topic. Now, one way to examine second language learning in the absence of grammar awareness comes from artificial language paradigms. These allow us to assess conscious awareness of a grammar rule at the level of individual learners, rather than manipulating training conditions. This gives us a finer-grained, though admittedly still imperfect, measure of implicitness or explicitness. The advantage is we avoid issues where conditions are manipulated, where, for example, a participant could gain explicit knowledge in an implicit condition or vice versa. The experiment we're presenting today uses the same kind of layout as a sort of paradigm originally invented by John Williams at the University of Cambridge, in which participants are exposed to a semi-artificial language with some hidden grammar regularities. Then, learning of these hidden regularities is measured covertly, and at the end of the experiment, awareness of the hidden regularity is assessed, usually through some kind of systematic debriefing interview. Now, reaction time results using this kind of setup have found evidence for rule-unaware grammar learning, as shown by slowdowns to rule-violating trials in the experiment. Note, however, that some studies have not replicated these findings. For today's study, I'd like to speak specifically about Battering and colleagues' 2014's experiment. In their experiment, they had the four semi-artificial language articles gi, ro, ul, and ne. Participants were told that two of these words referred to nearby objects and two referred to faraway things. So, for instance, the watch that I'm wearing could be called ro watch, whereas a professor on the other side of the world might be called ul professor. Participants were not told about a hidden regularity wherein two of these words refer to animate or living things, and two usually refer to inanimate or non-living things. Battering and colleagues then set up a reaction time experiment wherein participants said for each word combination whether the noun was living or non-living, and then whether it was near or far based on the pseudo word. Now, 1 out of every 7 trials violated the hidden rule that I've described above. The way the task was set up, slower responses to rule-violating trials would indicate learning of the hidden rule. At the end of the experiment, an interview is conducted to assess participants' awareness. And so the question is, will rule unaware participants show learning? In their results, they found that overall, participants were slower to the rule-violating trials, shown in red here, relative to the rule-adhering or canonical trials, shown in blue here. When the data are divided by rule-aware versus rule-unaware participants, they found that, yes, both participant groups showed signs of grammar learning based on the reaction time indices. Badrick and colleagues also had some event-related potential data to suggest differences between rule-aware and rule-unaware learners. This supports the validity of the distinction between the two groups. Now, the motivation for today's study is as follows. Badrick and colleagues' rule-aware participants gained awareness in incidental conditions. In other words, by noticing grammar patterns after sufficient exposure to the semi-artificial language. This might not reflect instructed contexts, where learners are given metalinguistic explanations at initial stages of learning. Note that many, not all, but many university second language teaching environments might be called instructed rather than incidental, to the extent that teachers give learners grammar rules and grammar explanations directly at early stages. So, we aim to extend Badrick and colleagues by examining how grammar learning differs when metalinguistic awareness comes from incidental versus instructed contexts. Our research question is stated as follows. Does L2 grammar learning differ when explicit rule awareness comes from incidental versus instructed contexts, as indexed by reaction time measures in an artificial language learning experiment? So, moving on to the methods. All of our participants were native English speakers at the University of Illinois at Chicago. Notice that we have different sample sizes between the incidental and instructed condition. Like I mentioned, these data were collected in two separate rounds of data collection. The incidental participants were in fall 2019, and the instructed participants were in early 2020. This slide shows more information about the participants and their language background. So, our experimental task was set up very similarly to Badrick and colleagues. Shown here is our task design. Notice that, like in Badrick and colleagues study, participants would be slower to the living, non-living response in the context of a rule-violating trial if the participant learned the rule. We used, of course, the same semi-artificial language as Badrick and colleagues, and 1 out of every 7 randomly interspersed trials violated the underlying rule. Okay, so here's a little demo of what the experiment looked like. Participants would read word combinations like nay, laptop. Is it living or non-living? Well, laptop is non-living, and nay corresponds to far, so here the answer is far. Here's the next trial. Gi, professor. Professor is living, and gi means near, and so on like that. Now, the procedure for the study followed Badrick and colleagues, except for 3 changes. First of all, in the reaction time task itself, the artificial language articles were presented separately before the nouns, rather than all on the same screen. This allows us to look into questions of prediction, which I won't discuss further in today's presentation. Also, we don't have a nap between blocks 1 and 2. I should explain that Badrick and colleagues 2014 was mostly a sleep study, whereas we're mostly interested in the second language acquisition side of it. Instead, then, we replaced it with just a 5-minute break. And finally, of course, we had a separate group of participants that got an overt and explicit rule explanation at the beginning of the study. So here are the procedures for the 2 groups of participants. They each filled out a language background questionnaire. They did a short vocabulary pre-training to become exposed to the artificial language words, and then they completed a reaction time task. The difference between the 2 groups is that the incidental participants did a debriefing interview at the end of the experiment, whereas the instructed participants were given a rule instruction before they started the reaction time task. So for the incidental participants, we had a systematic debriefing questionnaire, just like in Badrick and colleagues. Here's what the questions look like. Note that this interview followed a forking path based on how the participant responded. Participants were coded as aware if they described the correct pattern and if they reported having noticed it during the experiment prior to the debriefing. Otherwise, they were coded as rule unaware. So this is perhaps not a perfect categorization of different levels of implicitness versus explicitness, but it follows the rule aware, rule unaware distinction as in Battering and colleagues. For the instructed participants, they were shown the following screen before the main task. There is actually a rule that determines the correct choice between ul, gi, ro, ne in the majority of cases. Namely, gi and ul are usually used for living things, and ro and ne are usually used for non-living things. After you've read this additional rule and you feel like you understand it, press enter to continue. Now notice, this doesn't mean that the participants would have learned the rule 100% and be ready to show optimal task performance necessarily. We don't know that participants memorized the rule per se, but what is undeniable is that participants gained conscious awareness that there was such a rule. Even if they didn't memorize precisely which of gi and ul and ro and ne are mapped to which one, it would mean that over the course of the experiment, they could know that there was a relationship there. Okay, so it's undeniable in a sense that they have conscious awareness that there's an underlying grammar rule involved. So in our analysis, we conceptually followed Battering and colleagues. We looked at trials with correct living and non-living responses with reaction times lower than 3 seconds. Experiment data were divided into 8 epochs of equal length, and we performed the analysis of variance described here, looking at median epoch response times. Instead of comparing rule-aware versus rule-unaware participants, we compared instructed versus incidental participants. Okay, and we also performed a similar analysis for mean epoch response accuracies. So we did both the response time and the accuracy analysis. Yes, we did have the problem that we had different sample sizes for incidental versus instructed participants. So the question is, would our findings be spurious because of these sample size differences? One thing we did to attempt to address this is a bootstrapping procedure where we randomly resampled the data 10,000 times, and in each resampling we had an equal number of participants in the incidental and instructed conditions. Then we could examine histograms of p-values of these 10,000 p-values, one for each sampling, to allow us to determine whether or not the effects were stable. Okay, and so all of the effects that we're describing today in these main ANOVAs were confirmed with this visual inspection to show that they were stable effects. So for instance, this diagram here shows p-values for each iteration of bootstrapping for one given analysis. And so in this example analysis shown here, we would call this a stable effect because in all of the iterations, we had p-values less than 0.05. By contrast, at other times, there's cases where it's clear that having a statistically significant value was not a stable result. So for instance, the figure in the top right shows what we will call a stable effect. The one in the bottom right shows one where we do not support it with the bootstrapping analysis. Now, turning to the results. What I'm showing here are median epoch reaction times for rule adhering versus rule violating trials. For both the incidental and the instructed participants, there seem to be reaction time slowdowns to rule violating trials, indicating grammar learning. What's funny to note is that the incidental participants maybe needed an epoch or two before the effects became more pronounced, whereas the instructed participants seem to be more consistent. In the formal analysis we did, oh yes, I forgot to mention, we're only looking at participants with explicit rule awareness, and so we looked at the 14 participants that were coded as rule aware and retained in the analysis. So the ANOVAs found a main effect of trial type such that violation trials were slower than rule adhering trials. Also, we found a main effect of time point in the experiment such that participants became faster overall as time went on. However, there were no other significant effects, namely, or more specifically, there were no significant effects or interactions from experiment condition, most critically for a research question. In the accuracy analyses, What I'm showing now here are mean accuracies per epoch for the incidental versus instructed participants. Okay, in our planned by epoch analyses, we found a main effective trial type such that rule adhering trials had a higher mean accuracy than rule violating trials. Now, looking at these line graphs, however, it seemed that the epochs weren't quite so to speak, homogeneous. Namely, the incidental participants seem to show qualitatively different approaches to block 1 versus block 2. So we did a post hoc, let's call it exploratory by block analysis, where we compare block 1 versus block 2 instead of looking at the 8 epochs in the ANOVA. Okay, so in this analysis, running it just like the epoch analysis, but looking at blocks instead of epochs, we found a main effective trial type and a significant trial type by block interaction. Okay, turning now to our discussion. We've reproduced this finding of emerging rule awareness in incidental conditions, as in Badrink and colleagues 2014. However, we found no differences between incidental versus instructed participants, at least when we look at median reaction times or mean accuracies, which granted are imperfect measures of central tendency. This suggests, or our findings suggest, that the source of metalinguistic awareness, i.e. instructed versus incidental, may not play a major role in L2 performance, at least for certain forms in initial stages of learning in the context of the semi-artificial language. However, I might note a little more informally some apparent qualitative differences in how the two groups approach the task. Is it possible that the incidental participants over-applied and then under-applied the rule? Here's the accuracy plots again. What seems to be the case is that in the incidental condition, the participants over-applied the rule, so to speak, in that they really showed a drop in accuracy for the rule violating trials, but then they stopped applying the rule so much after the 5-minute break. Maybe something about how they handled the exceptions. Maybe they thought, well, if this rule isn't consistent, it's not a very good rule, and I'll just sort of proceed as before. By contrast, in the instructed condition, participants' accuracies were more steady throughout. Okay. However, notice that in the reaction time analysis, this kind of over-applying and under-applying isn't so apparent. Maybe reaction times are a more implicit measure of language processing. Maybe it's different than accuracy. So it points to some interesting differences there. And I think that this really brings me to this next question I want to put forth. What does the experiment really feel like to the participants? So for instance, maybe for the incidental learners, the rule isn't hard and fixed. When they see that there's exceptions, they change how they tune in and tune out of the rule. By contrast, for the instructed conditions, when participants are told the rule, maybe they feel like it's their job to apply the rule. Maybe they feel obligated to use the rule. And so it makes me ask, what are students' language ideologies regarding L2 grammar? Here, what the reaction time task isn't quite capturing is the kind of dark energy about how the participants feel or conceptualize the rule. So talking about some limitations or future directions, as I mentioned before, we had different participant cohorts, some in October, November, and then the other one was in January, February. We're collecting data where this is not the case, where incidental versus instructed is randomized, along with other changes to the experiment. Also, to bring up the ecological validity of the study. So even though there's studies in support of artificial languages generalizing to natural language processing, these findings might not generalize beyond just the laboratory. Also, the speed accuracy sort of differences we saw between reaction time versus accuracy-based analyses are something to take into account, which we can do with evidence accumulation models and other approaches not described here. And when COVID dies down and the lab opens back up again, we hope to collect EEG data to get finer grained measures of language processing. And I might note that EEG has been shown to detect effects that are not apparent through behavioral measures alone. So thank you for your attention. I look forward to some interesting questions and to some great critiques and feedback. Thank you so much to all these undergraduate research assistants that have helped me in this project throughout the years, as well as to our lab's principal investigator, Dr. Karen Morgenshort, as well as Dr. Laura Battering, upon whose work this study is based. Thanks also to our funding agencies, and thank you for watching.